So the first question here, Anag, is what about education of patients around their precision medicine choices, and what role can or should technology providers such as us play here in this particular field?
Well, as you and I have had plenty of discussions, Joydeep, education is crucial. And not, again, as it's not only in terms of here's this information about this technology, but it's the applicability of this technology that actually is key in the education. The second part of that question is how does technology play a role in providing this education? And one of the reasons that we are launching the Institute is to make it scalable, to reach out to as many physicians throughout the world as possible, to provide cutting-edge technology in a practical, usable manner. And I hope that you guys have a chance to log on to the website and see for yourselves what this information will provide and how it can help and benefit you currently.
Second question here is, where do you see precision medicine now, and where is it headed in the future?
Right, that's the million-dollar question always. What will the future hold? Well, let's begin with now. I've illustrated some cases of where the technology is currently. And I think, again, so much the technology will get there. But it isn't keeping up with technology. It's about utilizing what we have and what can we do with that technology and keeping it focused on the clinical realm. Just because we can do something doesn't always mean we should. We should always ask the question, why? Why are we doing this? How are we benefiting patients? As a medical doctor, I always put that in first thought. How does this technology benefit my patient? And if it does, I want to do it, irrespective of the cost. I want to do this because it makes a demonstrable difference in the care of my patients.
So I guess we have our first question here. In terms of how can the development and understanding of these new immuno-oncology biomarkers lead us to generate new and improved therapies?
Yeah, I think that's a great point. So, as I said before, problem with the current checkpoint blockers in use is really that most patients do not benefit from it. I think that's simply fair to say, although we have seen great responses, no doubt. So I think we need to get a deeper molecular understanding of what's going on there, really. And then if you think this through in terms of resistance mechanisms, I think it's very crucial to understand these resistance mechanisms and possibly develop therapies that could, circumvent these, like, for example, T790M in the EGFRI setting.
So how would you relate the effect of age of the patient in terms of the efficacy of immuno-oncology therapies? This is interesting. I don't think we saw the data out there, but is there one?
Yeah, I think data are still very preliminary. So I wouldn't want to make any firm statement on that. I think, given the fact that we do see severe side effects with these patients, it really, depends on the individual constitution of the patient from a clinical point of view, whether you could give such therapy or not. And the future and the ongoing trials will tell us whether, older and, so older patients and to which extent they actually benefit from these therapies.
Okay. This first one is, how does a rare disease become common enough to become part of routine screening?
Well, that depends on your definition of a rare disorder. There are rare disorders, at least according to our national law on rare diseases, that are the most important cause of intellectual disability or of inherited intellectual disability. And a rare disease becomes common enough to be part of a routine screening program if you are at tertiary level referring center. I totally agree that these things should be given, sort of handled by people who have the knowledge and the tools and everything. So this is something that Some centers have to develop. This is not family medicine, but definitely there are centers who develop the skill and the knowledge that become a referral point for certain diseases, for which then they build an incredible professional skill and experience. So, but there are rare disorders that are much less rare than what we think. What is your opinion about doing exome instead of disease panels?
Yeah, that's the next one.
As I said, as a question of waiting, you weigh your options. Do I want everything that's in that's expressed, no matter what, or do I want only what I want at the higher coverage? I decided that I want only what I want with a higher coverage. I don't want to have to deal with a BRCA1 mutation in a 5-year-old child. Right. Where the problem is intellectual disability, because I'm adding problems to problems. I want to be able to possibly solve or give an answer to the current problem clinically.
So you mentioned improving prevention, detection, diagnosis, treatment. Of the 4, where should we invest our resources to change the cancer landscape?
Okay, so I think if you had to just choose one, I do think probably detection. Prevention, I think, is beyond the scope of NGS. We know our public health physicians work, to send out messages about lifestyle that we all choose to ignore. So that's not, I don't think you can spend your money there. But if we can detect earlier, then it allows us to plan and develop an adaptive, strategy for a patient should they go through that disease course. If we can identify early and detect the disease, there's the possibility of eradicating it, but if not, at least it gives us time to plan for a more fluid approach.
Can I ask you a question
Sure.
on that, just to follow up to this, right? So you talked about disease management once the patient has a disease, and you provide surveillance to watch for recurrence. There's also this concept, and it is still the best drug for cancer, and best indicator of survival is detecting it one stage earlier rather than not.
Yeah.
And therein comes this concept of health management rather than disease management, right? So you look at people at risk, whatever that might mean, and being able to provide them a tool for peace of mind or otherwise to look at things. So what's your perspective on that?
Yeah, I think there's a huge opportunity to encompass a sort of a form of maybe adjunct testing in screening programs, in general health screens, to maybe screen out key, a few key mutations that we know will forebode the coming of a disease.
Yep.
So I think there is scope for maybe earlier than those seasons that I mentioned in detecting at the very earliest stage or in screening populations.
So what do you mean by uniformity of gene panels, and why is that important?
That's a great question. So uniformity of gene panels means every panel has sets of amplicons, and you want to ensure that all those amplicons amplify as uniformly as possible. If you have non-uniformities of amplification, that means your average sequencing depth has to be pushed up to get to the minimum required for the variant discovery or variant identification that you need. So uniformity is important because you can sequence less and get the same answer.
So just as a corollary to that, is that important only in liquid biopsy, or do you expect it to be important in other areas?
It's important in pretty much every area. So cancer sequencing, inherited sequencing, in nearly every kind of sequencing, the more uniform it is, the less you're wasting the sequence in effect.
Next question, how and why do you see the immune repertoire assay for TCR diversity being used in research?
Yeah, that's another good question. So there's a couple of areas we see. One that I outlined perhaps more extensively in this talk, obviously in the area of immuno-oncology, which is a very hot research topic right now, for looking at what is going on in the immune system as the patient's responding. But you can also see in human disease research, there might be potential of use in autoimmune disorders, lupus, MS, rheumatoid arthritis, to understand what is going on directly inside the patient's immune system, to give you a picture of what is actually happening in real time.
So how can you associate metagenomics to lifestyle changes in dieting habits?
Yeah, so as I told a bit, but I can make a more clear answer to that. So you see that gut bacterial community is decide even at the time you're born completely free of germ, and at the time you're born, it's already a lot of things which impacts and tell you what of the bacterial species will be developed on your guts. But then, of course, you can have lifestyles such as stress life, smoking habits, sports habits also, which can have an influence in the diversity of the species, also in the diversity of the genes. And the diet habit, of course, we find out links in between high fiber consumption and better bacterial diversity and gene diversity. On the diets, I will say just have as much as diversity in your diets. Try to minimize the meat consumption, but also the milk consumption and so on. It's find out that it's better for the health to have more diversity in the diet, more diversity in the guts in terms of species. That's easy to understand.
Can you comment on the link between food habits and gut microbiome and autism?
Okay, food habits and autism, I don't know the link. Maybe they are. Gut microbiome and autism, there are 1 on 5 people having autism who have been treated with antibiotic at the age of 3 or 5 years old. At the times the gut microbiome develops, so maybe you get a perturbation there. I don't know, it's 1 on 5. It's not like enough to say, don't treat a baby with an antibiotic. So, but I think any disturbance you can have on your gut affects your brain, because you have a brain-gut axis, which means brain-gut axis. It means that some bacteria produce metabolites which go on the blood and which go in the brain. I mean, you have as much as synapse in the gut that you have in the brain. So you have connection in between by blood fluids, and whatever happened there go to your brain. One way to go there, if you stress, just like before to give a presentation, you have pain in here. Yeah, it's because you have links in between, right?
What's the main driver between everything moving to NGS at some point, and as opposed to arrays, which can also detect SNPs, all kinds?
I think we are moving to NGS just for an economical reason, because, as I said, the IVF cycle is quite expensive, and genetics is also quite expensive. If we do microarrays and Sanger sequencing and very different techniques with, as I said, with a lot of people working at the same time. So the reason to move to NGS is just because it is cheaper. And regarding to aneuploidy study, we have even better resolution, because now we can identify mosaic system.
And is that the same trend you're seeing even in carrier screening? So do you think carrier screening will move eventually all to NGS, or is that still within the domain of microarrays?
Yeah, I think carrier screening is moving to NGS. But the problem moving carrier screening into NGS is that we will have a lot of variants of uncertain significant. So we will not be able to give recommendations to the couple to go to an IVF cycle or not.
So what are your thoughts and ethics surrounding the future of human identification?
Well, this is a very important topic, as I tried to outline in my presentation. STR profiles are non-coding, so we are using non-coding STRs, which we are required to by our legal systems, which is great, because that means we don't have so much. It's easy to protect non-coding data. The problem is they are still individual specific. It only needs a few kilobytes to handle and store these data, and you can discriminate one person among the entire world population easily in a theoretical experiment. So we need to be aware that this information could be used in a different way, and this is why we need to follow rules that help anonymize these samples. We are not publishing these samples. We keep them safe. If we move to prediction, then we are looking at DNA areas which are no more individual specific, but many people share it. And that means the protection from a privacy standpoint is not there anymore. But there are other reasons why we need to protect this data, because they could potentially be misused in different contexts. So this is why I think it's very important that social scientists do research here that is acknowledged, because they help us understanding and convey this information. And if we look at funding programs 20 years ago, it was about technology. If we look at the funding program today, there is still technology, but there is a large part of social and societal impact.
So what do you need to do next to improve the analysis of ctDNA?
That's a really good question. That's quite a broad question. I think we know what we need is a standardization, number one. I think we need, because this is from how we collect the blood, to how we process the blood, to how we extract the ctDNA, to how we analyze the ctDNA. I don't think there is an answer here. I need better panels, or I need more limit of sensitivity. We need a proper workflow that answers all these questions. Is our blood collected in the right way? Is the cfDNA extracted in a way that minimizes loss of material? And of course, what we need, and I think that was the whole purpose of my talk, is customizable panels, so the ability to decide what you want to look at with very, very, very high sensitivity, being able to detect ctDNA at a very low allele frequency.
Back to CRISPR. As a research, do you think CRISPR should be used in the clinical offering, and do we know enough about it?
That's a good question. We've gone from creativity in research to liquid biopsies to CRISPR. Well, I'm not an expert in CRISPR. I'm going to take an educated guess in here. I don't think we know enough about it. I mean, we heard Luis Alcaraz talking about how CRISPR seems to be coming into the world of fertility. And the more we read about CRISPR, the more papers we find about editing bad genes out, or removing traits that we don't like. Do we know about this? I don't think we do. I don't think where we are at the moment to put it into the clinic, might be a bit risky. Having said that, is by porting these tools towards the clinic where we're going to learn more about there. So I think it's a slightly of a catch-22 here, isn't it?
So it's more science to be done, both in terms of understanding ethics, but also off-target effects and things that...
Oh, God, the ethics of CRISPR. We could spend probably a whole afternoon talking about the ethics of CRISPR. Is it ethical to,
Yeah.
I mean, when we're talking about disease, it might be. I mean, probably it's ethical. When we're talking about designer babies, as we were talking before, that's a totally different ball game. Yeah. And I don't know. Coming back to, ethics is an important part of that. Science behind this. Yeah. I'm very much pro doing more science before this thing gets into the clinical sphere.
Understand.